Hello, everyone. We are the Group 6 and we are about to discuss Chapter 7, Direct Manipulation and Immersive Environments. In this chapter, it will bring us to the principles of direct manipulation and how they are used in the interface. This also goes into immersive environments, including augmented and virtual reality. Direct manipulation interface is an interaction style in which the objects of interest in the user's interface are visible and can be acted upon via physical, reversible, incremental actions and replacement of typed commands by appointing action to the objects of interest that receives immediate feedback. So from the word itself, direct, that means without intervening factors or intermediaries. And so by that we can manipulate something or the interface directly that we receive the immediate feedback. Just like for example, when we're using a touch screen mobile device, looking at an image and when we want to whether zoom in or zoom out, and by using our fingertips, we can make it zoom out or zoom in by pinching in or pinching out. So this action is an example of a direct manipulation interaction where we act to manipulate our phone via physical touch and directly receive a feedback to it. And the other classic example of direct manipulation in computers is by manipulating the mouse or keyboard, like when we want to transfer the file from a folder to another folder. So what we're gonna do is to drag the file from a folder to another one in order to move it or in order to transfer it. And aside from that is we can also do the copy paste. But of course, we're still gonna control the mouse on the objects of our interest and it's still under the direct manipulation interface. Direct manipulation as a concept has been around since before computers. The metaphor of direct manipulation works well in computing environments and was introduced in the early days of Xerox PARC and then widely disseminated by Schneiderman. One of the favorite examples of direct manipulation is driving the automobile. The scene is directly visible through the front window and performing the action of stepping the brake or holding the steering wheel. And if it goes to somewhere that needs to turn left, the driver will simply rotate the steering wheel to the left. The response is immediate and the scene changes as the driver refines the turn compared to typing a command or selecting a button from a menu to turn left in the 30 degrees. Driverless cars may soon respond to commands like you'll just say where you want to go and the car will lead you to that way. But they are a long way for matching the skills of drivers at the wheel while navigating roads. There are three principles and attributes of direct manipulation. So the first one is the continuous representation of the object and actions of interest with meaningful visual metaphors. So in this case, users will be able to view visual representations of the things with which they will be able to engage. They can observe the repercussions of their actions on the system status as soon as they take them. For example, when moving a file using drag and drop, users can see the initial file displayed in the source folder, select it, and as soon as the action was completed, they can see it disappear from the source and appear in the destination, an immediate confirmation that their action had the intended result. The second one is the physical actions or process of labeled interface objects instead of complex syntax. In this type of action, it was invoked physically via clicks, button presses, menu selections, and touch gestures. In the move file example, the drag and drop has a direct analog in the real world, so this implementation for the move action has the right signifiers and can be easily learned and remembered. While the rapid, incremental, reversible actions whose effects on the objects of interest are visible immediately, so in this system, state is visible. It's simple to verify that each operation produced the desired effect. As a result, when users make mistakes, they should be able to understand the source of the error immediately away and fix it quickly. In command line interfaces, on the other hand, a single user command may have many components that might create an error. For instance, in the example below, the name of the destination folder contains a typo or a wrong spelling. Instead of measuring usability, it tends to be the measuring u sub LTY. So the system simply assumed that the file name should be changed to measuring usability or the u sub LTY. As a user, because of this direct manipulation interface, we tend to report these positive feelings that we used to show in result once we've done at the objects of our interest. Given the fact of using the said three principles, it is possible to design systems that have these 7 beneficial attributes. The novices can learn basic functionality quickly, usually through a demonstration by a more experienced user. So novices means a person new or inexperienced in a field or situation. Expert can work rapidly to carry out a wide range of tasks, so on and so forth. And of course, as a user, by using the principles, we can have these beneficial attributes like we tend to have the mastery and confidence to retain and show enjoyment on using it, the desire to explore more of its aspect, or even to show demonstration to the person who's new to it or has an experience in using the interface, just like what I've mentioned earlier about the novices. And just like what we've seen in the YouTube, that many YouTubers choose to have video tutorial or demonstration as their content. The effectiveness and reality of the direct manipulation interface are based on the validity and strength of the metaphor chosen to represent the actions and objects. The translational distance between users and the representation metaphor, which will be referred to as strength, is one approach of trying to analyze and characterize the direct manipulation metaphor. So these are the example of translational distances: the weak, medium, strong, and immersive. Weak direct manipulation is what can be described as basic manipulation. There is a mouse, trackpad, joystick, or similar device translating the user's physical action into the virtual space using some mapping function. So example for this is the early video game controllers, and as what we've seen in the images, like the joystick, trackpad, and the mouse. The next one is the medium direct manipulation. It is the next step along the continuum. The translational distance is reduced, and instead of communicating with the virtual space with the device, the user reaches out and touches or moves and grabs the entities in the on-screen representation. Like for example, for this is the touch screen devices, or the multi-touch device, which has the bigger and the larger screen. Next is the strong direct manipulation that involves action such as gesture recognition with various body parts. It may be the user's hand, foot, head, or full body, whatever controls the action that is virtually placed inside a physical space. Like for example, for this is the data glove that recognize the gestures of the hand, and also the dance recognition, which recognize from the various actions from head to foot, and ato ni siyang kakita sa mga arcade, especially nga naa siya sa Ayala and also sa SM or sa Gaisano. And lastly, the immersive direct manipulation. So in this dimension, direct manipulation is combined with virtual reality. The users put on glasses or some other device and they are the inside a space. The users can see themselves and they can even walk or fly through the space by walking, leaning in, and so on and so forth. So the scenery changes with their moves or with the moves of a person. And for example, for this is the VR. Have you ever heard about the VR? That means virtual reality. And it was so expensive. And aside from the VR is the Oculus Rift, or just like the proposed plan of Mark Zuckerberg about Meta. Problems with direct manipulation does exist. So there are at least 4 problems that was stated here. So the first one is the content of graphic representation was a complication for vision impaired users. Second one is the graphic representation that may take up excessive display space, where direct manipulation designs may consume valuable screen space and thus force valuable information off screen, requiring scrolling or multiple action. So this is an issue in the mobile world where screen space is very limited. The third is the users must learn the meanings of visual representation and graphic icons, that titles that appears on icons when the cursor is over them offer only a partial solution. And the fourth one is the visual representation that may sometimes be misleading. A successful direct manipulation interface must present an appropriate representation or model of reality. With some application, the jump to visual language may be difficult, but most users and designers can hardly imagine why anyone would want to use a complex syntactic notation to describe an essentially visual process. So we have here the advantages and disadvantages of direct manipulation. And as what we've seen here, there are at least 6 of advantages and 2 for the disadvantages of direct manipulation. So in the advantages, it is visually presents task concepts, allows easy learning, easy retention, errors to be avoided, and it encourages exploration. And lastly, it affords high subjective satisfaction. While the disadvantages, it may be hard to program it, and the accessibility requires special attention. So there will certainly be many future variation of and extensions to direct manipulation, but the basic goal will remain similar: the comprehensible interfaces that enable rapid learning, predictable and controllable action, and appropriate feedback to confirm progress.
Some examples of direct manipulation. No single interface has every admirable attribute or design feature such an interface might not be possible. Here are some examples of direct manipulation that has sufficient features to win the enthusiastic support of many users. First is geographical system, including GPS or global positioning system. It was a natural progression to create systems to represent our current location as to where we are and a target location or where we want to go. This has been used by the travelers or delivery man in a situation where we get to order stuff online and it will be delivered to our doors for they have the access already on our specific location. These type of systems became available as commercial GPS systems for cars, for walking, and even for the mobile phone. Being able to directly see the alternatives on the devices as well as how to move from the current location to the target location, including manipulating routes, is another application of direct manipulations. Other examples of geographical systems are Google Maps, MapQuest, Google Street Views, and etc. Second is video games. Games have come along with various controls including full body, multiple objects of interest, full stereo sounds, detailed graphical environments, changing backgrounds, and the possibility of multiple players sitting physically next to one another or virtually across the globe. Some examples for this are the Nintendo, Sony PlayStation, and Microsoft Xbox. These gaming platforms have brought powerful 3D graphics hardware to the home and have created a remarkable international market. Gaming experiences are being enhanced by combining 3D user interface technologies such as stereoscopic 3D, hand tracking, and finger count gestures. Here are some lists of the gaming genre acronyms that are more widely used. First is the AA or the Action Adventure Games. Second is the ARPG or the Action Role-Play Games. Third is the FPR or the First Person Shooter. Fourth is the MMORPG or the Massively Multiplayer Online Role-Playing Games. Fifth is the MOBA or the Massive Online Battle Arena. Sixth is the RPG or the Role-Playing Games. Seventh and the last one is the RTS or the Real-Time Shooter. There is a wide genre of games and the borders between genres are becoming blurred. Some games are single-player games, others have multiple player games. Players can be in the same physical space or a different physical space but shared virtual space. One is the computer-aided design and fabrication. Most of the computer-aided design are CAD systems for automobiles, electronic circuitry, aircraft, or mechanical engineering use principles of direct manipulation. With such applications, the designer may see a circuit schematic on the screen and with mouse clicks be able to move components into or out of the proposed circuit. When the design is complete, the computer can provide information about current, voltage drops, and fabrication costs and warnings about inconsistencies or manufacturing problems. The pleasure of using these systems stems from the capacity to manipulate the object of interest directly and generate multiple alternatives rapidly. With the advent of these types of systems, it can be graphical, sophisticated 3D displays generated and also the 3D printing technology. The next is the direct manipulation, programming, and configuration. Performing tasks by direct manipulation is not only the goal. It should be possible to do programming by direct manipulation as well, at least for certain problems. For example, the moving drill press or a surgical tool through a complex series of motions that are then repeated exactly. Automobiles seating positions and mirror settings can be set as a group of preferences for a particular driver and then adjusted as the driver settles in place. Likewise, some of the professionals' television camera supports allow the operator to program a sequence of pans or zooms and then to replay it smoothly when required. Programming of physical devices by direct manipulation seems quite natural, and an adequate visual representation of information may make direct manipulation possible in other domains. The 2D and 3D interfaces. There are some designers dream about building interfaces that approach the richness of 3D reality. They believe that the closer the interfaces are to the real world, the easier usage will be. This extreme interpretation of direct manipulation is a dubious proposition since user studies show that disorienting navigation, complex user actions, and annoying occlusions can slow performance in the real world as well as in the 3D interfaces. 2D interfaces are designed to be simpler than the real world by constraining movement, limiting interface actions, and ensuring visibility of interface objects. While the strong utility of pure 3D interfaces for medical, architectural, and product designs and scientific visualization purposes means that they remain an important challenge for interface designers. For some computer-based tasks, such as medical imagery, architectural drawing, computer-assisted design, chemical structure modeling, and scientific simulations, pure 3D presentations are clearly helpful and have become major industries. By using a medical simulations inserted into a large-scale visualization using cave technology, physicians were able to find a solution that would not have been possible with the actual surgery. 3D environments are greatly appreciated by some users and are helpful for some tasks. They have the potential for novel social, scientific, and commercial applications if designers go beyond the goal of mimicking 3D reality.
Teleoperation and presence. Teleoperation has two parents, the direct manipulation in personal computers and process control, where human operators control physical processes in complex environments. Typical tasks are operating power or chemical plants, controlling manufacturing, surgery, flying airplanes or drones, or steering vehicles. If the physical processes take place in a remote location, we talk about teleoperation or remote control. And to perform the control task remotely, the human operator may interact with the computer, which may carry out some of the control tasks without any interference by the human operator. This is an example of teleoperation and presence, where the first one is the telehealth program. The nurse director at the Landstuhl Regional Medical Center demonstrates using the telehealth otoscope to conduct a real-time tympanic membrane exam. And the second image is the robotic surgery, that the surgeon sits at the computer console and control the robotic camera and surgical instruments remotely. The architecture of remote environments introduces several complicating factors. The first one is the delays. The network hardware and software cause delays in sending our user actions and receiving feedback. A transmission delay, or the time it takes for the command to reach the microscope. These delays in the system prevent the operator from knowing the current status of the system. The second one is the incomplete feedback. The devices originally designated or designed for direct control may not have adequate sensors or status indicators. And the third one is the anticipated interferences. For instance, if a local operator accidentally moves the slide under the microscope, the positions indicated might not be correct, and a breakdown might also occur during the execution of a remote operation without a good indication of this event being sent to the remote site. Telepresence was initially defined by Martin Minsky in the year 1980, but today the operative term is presence. The concept was that of not being remote but giving the feeling of being there. The commercial market is seeing a set of technologies called mobile remote presence or MRP systems. These are advancing video conferencing system and allowing remote workers to have a feeling of presence. And there are some of the company creating these devices include Suitable Technologies BIM, Manta Robot, Double Robotics, and BGO. The controlling of these devices is another form of application of direct manipulation. And even Skype, the other technologies is a shared workspace called Immersive Board, where the user is co-located but can work on the same screen. In the augmented and virtual reality, the gurus of virtuality are promoting immersive experiences. Then the miniaturization of electronics has provided less bulky gear to do that exploring. And the hand-mounted displays are available from various manufacturers such as the Oculus Rift, Razer OS VR, HTC Vive, Sensix, Sony Glasses, and Colhimos. The bulky gloves are being placed or replaced by more lightweight materials and less cumbersome connections, while the Magic Leap has just applied for a patent for a contact lens to facilitate augmented or virtual reality. Graphic researchers have been perfecting image displays to simulate lighting effects, textured surfaces, reflections, and shadows. The data structures and algorithms for zooming in or panning across an object rapidly and smoothly are now practical on common computers and even some mobile devices. The immersive environment has some problems, including the simulator sickness, nausea, and discomfort from wearing head-mounted gear and the other equipment. But some of these problems are minimized by less jumpy graphic transitions, and that is why it needed a better understanding of the usability challenges, such as how much reality should be incorporated, and when and how it can improve the user's experience. The augmented reality enables users to see the real world with an overlay of additional information. For example, while users are looking at the walls of a building, their semi-transparent eyeglasses may show the location of electrical wires and stud work. The medical applications such as allowing surgeons or their assistants to look for a patient while they see in an overlay of a sonogram or other pertinent information to help locate it more also seem compelling. The augmented reality could show users how to repair equipment or guide visitors through cities. Example for augmented reality. An interior designer walking through a house with a client should be able to pick up a window stretching tool or pull on a handle to try out a larger window or to use a room painting tool to change the wall colors while leaving the windows and furniture untouched. And the other one is the companies like IKEA or IKEA are providing augmented reality tools so that customers can visualize the products via their catalog in their own homes and rooms. In virtual reality, it breaks the physical limitations of space and allows users to act as though they are somewhere else. Practical thinkers immediately grasp the connection to remote direct manipulation, remote control, and remote vision. Many medical successes using virtual environments because virtual worlds can be used to treat patients also with the fear of heights by giving them an immersive experience with control over their viewpoint and movement. And the another dramatic result is that immersive reaction or immersive environments provide distractions for patients so that some forms of pain are controlled. And the immersive virtual reality environment has been used to treat military personnel suffering with PTSD or the post-traumatic stress disorder. And virtual reality or virtual worlds can also be used for positive computing and wellness issues.
Among interactive systems that provide equivalent functionality and reliability, some systems have emerged to dominate the competition. Often, the most appealing systems have an enjoyable user interface with customized user generated content that offers a natural representation of the tasks, objects, and actions, hence the term direct manipulation. These interfaces are easy to learn, to use, and to retain over time, that novices can acquire a system subset of the action and then progress to more elaborated ones. And the action also are rapid, incremental, and reversible, and they can be performed with physical movements instead of complex syntactic forms. Using direct manipulation principles in an interface does not ensure its success. A poor design, slow implementation, or inadequate functionality can undermine acceptance. For some applications, other approaches may be more appropriate. However, great potential exists for multiple and varied applications of direct manipulation concepts.